Hello guys, what's up? Welcome to our fourth video. This episode we're gonna talk about heat transfer. Now radiation. Radiation is the transfer of heat through electromagnetic waves. In radiation, there is no contact or medium needed. Hot objects give off infrared radiation which can travel through space or air and be absorbed by other objects. So this example is very clear because it says infrared radiation can travel through space or air. In here is traveling through air and absorbed by the hands of this boy. Now, in here we have the three formulas for conduction, convection, and radiation. Now I'll explain what the letters mean. So, sigma stands for the Stefan constant. Epsilon stands for emissivity. A stands for area. T4 stands for absolute temperature. And T stands for time. Now, in convection, Q stands for heat transferred, H stands for heat transfer coefficient, A stands for area, change in temperature stands for temperature difference, and T stands for time. Now in conduction, Q stands for heat transferred, K stands for thermal conductivity, which in this one depends on the material given. A stands for area, change in temperature stands for temperature difference, T stands for time, D stands for thickness of the material, which also depends on the material given. Here we have an example of conduction. A metal rod is 0.5 long and has a cross-sectional area of 0.01 square meters. One end of the rod is kept at 100 Celsius and the other one at 25. The thermal conductivity of the metal is 200 watts per meter per Kelvin. Find how much heat is transferred to the rod. So, first, we check the data. The thermal conductivity is 200, distance 0.5, area 0.01, and change in temperature should be subtracted because here you have 100 and the other 25, it should be subtracted, which is 75. Now we can place it into the formula. Now we have to multiply 200 times 75 times 0.01, which gives 150 over 0.5, which gives 300 joules. So 300 joules are transferred through the rod. Now we have an example of convection. A metal plate with an area of 0.5 square meters is in contact with hot air. The air has a temperature difference of 40 degrees Celsius between the plate surface and the surrounding air. The heat transfer coefficient of the air is 25 watts per square meter per Kelvin. Find the rate of heat transfer. So, first of all, we have to look for the data, which is already identified. Area is equal to 0.5 meters. Heat transfer coefficient is 25 watts per square meter per Kelvin. And change in temperature is 40 degrees Celsius. So, now we just need to multiply, which is 0.5 times 25 times 40, which gives us 500 watts. Thanks for your attention. That's all for today.